and welcome to this video walkthrough of the AQA P3 physics paper from May 2014. I'm going to take you through how to do the paper in this session. So we start with a beautiful x-ray of a human skull, and we need to use the answers from the box to complete the sentence. So when x-rays enter the human body, soft tissue transmits, that means allows it to pass through, and bone absorbs the x-rays. The x-rays affect photographic film in the same way that light does. Okay, so we've got the total dose of x-rays received by the human body when different parts are x-rayed. Okay, calculate the number of head x-rays that are equal in dose to one pelvis x-ray. So one pelvis is 60 and a head is 3, so we need to do 60 divided by 3, which is 20. What is another use of x-rays? That cleaning stone teeth would be ultrasound, as would scanning babies, killing cancer cells. Okay, we've got a girl standing on a diving board and we're asked to calculate the moment of the girl's weight around point A. So moment equals force times distance. The force is 600 newtons. The distance is 5 meters. So 600 times 5 is 3000 Newton meters. Then we've got a girl at a different place on the diving board. Okay, the diving board is not turning. The total clockwise moment is balanced by the total. So when we're looking at balanced moments, we're looking at clockwise and anti-clockwise moments. Okay, so we've got a graph now showing how the force varies with distance from point A, and we're asked to determine the upward force when there are 3 meters away. So we're going to go to 3 meters. We're going to follow that line along, use a ruler to try and make it a straight line. So we've gone 2 small squares up. Now each one big box is worth 1,000, so each small box is worth 200, so that's going to be 3,200, 3,400 newtons. What conclusion can we make from this figure? As distance increases, the upwards force needed increases. It's only 1 mark, so we're not looking for any terms like directly proportional in this one. Okay, comparison between digital cameras and human eyes. So which bit do we find where? The cornea is in the human eye. A lens is in both. Pupil, that's just in the human eye. And a charge coupled device would just be in a digital camera. Okay, short sight can be caused by the eyeball being that's long. In short-sightedness, the image is produced before it hits the back of the eye, so it's too long. Spectacles can be worn to correct short sight. Here's some information about spectacles. Which lens should we use to correct the short sight? So we are looking for a diverging lens. Okay, because it's meeting too soon, we want those rays to be spread out a bit more, so it's going to be lens A. It is diverging. Okay, every lens has a focal length. Which factor affects the focal length of a lens? Right, well, it's not going to be the colour. Can't be the size of the object being viewed. It's got to be the refractive index. Okay, a lens has a focal length of 0.25 meters. Calculate the power of the lens. So the equation we need is P equals 1 over F. We get that off the equation sheet. So 1 divided by 0.25 put that into the calculator. Gives me an answer of 4 diopters. Okay, laser eye surgery can correct some types of eye defect. What is another medical use for a laser? Okay, so it's definitely not going to be used for imaging the lungs, and I wouldn't really want a laser pointed at my lungs. Detecting broken bones? Probably not. Cauterizing? That means burning the edges of open blood vessels is the answer. Okay, here's a convex lens being used as a magnifying glass. We've got an object height of 14 millimeters and the image height is 70 millimeters. We're asked for the magnification. So again, look at our equation sheet. Magnification is equal to the image height over the object height. So that's going to be 70 divided by 14. Again, pop that into the calculator and that gives us 5. Okay, centre of mass. The centre of mass of an object is the point at which the mass of an object may be thought to be concentrated. Okay, figure 6 shows an oval shaped piece of card. Draw an X such that the centre of the X marks the centre of the mass. Right, so what you want to do here, when you've actually got this on paper, is fold it. So you're going to fold it so that you're matching there, so you've got a centre of symmetry there. Fold your paper again to find the exact centre of symmetry down the middle, and that's where you put your X. Yeah, not so easy to do on a computer screen. Or alternatively, you can use a ruler to measure it. For the next part of the question, we're looking at a practical. So we've got various pieces of apparatus, and we're going to have to put these sentences in the right order to describe how to find the centre of mass. So we'll start off with, make 2 holes in the card with each hole near to the edge of the card. Right, so we want to do something with holes in the card. If we look through these questions, we've got 2 options that talk about the holes. One that says repeat using the other hole, and we already know that that's the last one. Or C, put the pin through one of the holes in the card and hold the pin in the boss. So C goes next. Then we want to talk about doing something with the pin. We've just put a pin in, tie the mass to one end of the string and then hang the string from the pin. Looks sensible. And then that would leave D, draw a line on the card marking the position of the string. That works. And then repeat with another hole. Okay, we've got a person in a wheelchair. Tipping the wheelchair at a large angle may cause it to become unstable and to topple over. How could the design be changed to make it less likely to be toppled? Tick 2 boxes. So many people miss the 2 and just tick 1. Okay, so to make things less likely to be tipped, we lower the centre of mass or make the base wider. So lower the person's seating position will lower the centre of mass. Moving the wheels further apart will make the base wider. Okay, here's a musician on a moving platform and the parts of a machine used to lift the platform up and down. What is the name given to a system that uses liquids to transmit forces? Hydraulic. Okay. To move the platform upwards, the liquid must cause a force of 1,800 newtons to act on the piston. The cross-sectional area is 200 centimetres squared. Calculate the pressure in newtons per centimetre squared. So pressure is equal to force over area. So 1,800 divided by 200. It's the same as doing 18 divided by 2. Gives us 9 newtons per centimetre squared. A new development is to use oil from plants as the liquid in the machine. Growing plants and extracting the oil requires less energy than producing the liquid normally used in the machine. Using the oil from the plants gives a what advantage over the liquid usually used? So if it's using less energy, well, that's not ethical or social. It must be an environmental one. Okay, we're using less energy, we're using less resources. Okay, investigating the strength of electromagnets. Figure 10 shows 3 electromagnets. A student hung a line of paper clips from each electromagnet. Complete the conclusion. Increasing the number of turns of rail wrapped around the nail will increase the strength of the electromagnet. Which 2 pairs should be compared? So we want 2 that have different numbers of coils on. and we want two that are the same in other respects. So if we look, the other difference is the current is the other way around. So these two, A and B, could be compared, or we could compare A with C. Okay, suggest two variables that the student could control. So we want to keep the same current, and we want to use the same material for the nail, the same type of nail. Okay, the cell is swapped around to make the current flow in the opposite direction. What is the maximum number of paper clips that can now be hung from a line? So, if we look at this, in B and C, they've switched the current around but got the same number, of course, and they've got 1, 2, 3, 4, 5, 6 on that one, 6 on that one, it stayed the same. So if we've done that with A, we started with 4, it should still be 4. Changing the direction of current doesn't affect the strength. Okay, electromagnetic is changed to have only 10 turns of core wrapped around the nail. Suggest the maximum number of paper clips. So if we're halving the number of turns, then we're probably halving the number of paper clips, so that's going to be 2. What is ultrasound? Ultrasound has a frequency sound with a frequency above 20,000 hertz. Okay, using ultrasound to measure the depth of water below a ship. A pulse of ultrasound is sent out from an electronic system on board the ship. It takes 0.8 seconds for the emitted ultrasound to be received back at the ship. What is the depth of water? So if it's taken 0.8 seconds to get down there and back, it's only taken 0.4 seconds to get there. We've got the speed. We know the equation is speed is distance divided by time. Now we need to rearrange that equation. So we've got speed times time equals distance. So 1,600 times 0.4, and we're going to plug that into our calculator. Okay, so that gives me 640, which seems reasonable. Okay, ultrasound can be used in medicine for scanning. State 1 medical use of ultrasound scanning. So looking at babies, fetal scanning. Images of the inside of the human body can be made using computerized tomography or CT scanning. That uses X-rays to produce these images. What is one disadvantage of using a CT scanner compared with ultrasound scanning? So it has a higher resolution than ultrasound. That means you can see smaller details. But the disadvantage, it is ionizing. I-N-G. Radiation can be harmful. Okay, man-made satellites can orbit at the Earth as shown in figure 14. Satellite experiences a resultant force directed towards the centre of the orbit. This is called the centripetal force. What provides the centripetal force? Gravity. What two factors determine the size of the centripetal force? The mass of the satellite and the distance between satellite and Earth. Table 4 gives data for 5 different satellites orbiting the Earth. State the relationship between the height of the satellite above the Earth's surface and the time taken. So, as the height increases, the time taken also increases. Okay, state the relationship between the time taken for it to orbit the Earth and the mass. Yeah, that's going up, but that's going all over the place. There is no relationship. Over 300 years ago, the famous scientist Isaac Newton proposed with a thought experiment the idea of satellites. He suggested that if an object was fired at the right speed from the top of a high mountain, it would circle the Earth. Why did many people accept Isaac Newton's idea as being possible? Because Isaac Newton was a respected scientist who had made new discoveries before. Okay, transformers. There are 2 types of transformer, step up and step down. Describes the similarities and differences between a step up transformer and a step down transformer. Include details of construction, including materials used, and the effect the transformer has on the input potential difference. You should not draw a diagram. Okay, so both types have a soft iron core and a primary and secondary coil of wire are wrapped around this. These coils of wire are insulated with a plastic coating. In a step up transformer, there are more turns on the secondary than the primary, so the PD increases. In a step down transformer, there are more turns on the primary than the secondary, so the PD decreases. Okay, mobile phone chargers use a different type of transformer which is smaller and lighter than the traditional transformer. What name is given to this transformer? It is called a switch mode transformer. Thank you for watching. I hope this has been useful.